Okay, next one. I'm still saying smart polymers. So what's smart polymers? So here's a demonstration of smart windows. So this window, you have to use such a device like this. So here say, you can say here's a window. It's a 2 panels. So it's no electric field, no voltage applied. So you can say it's a light can transmit. So you can say it's women. But however, if you apply electric field in a left panel, so it's black. So that means you can change the transparent to the dark. So that means we call it smart window. So a smart window is usually a smart window is a liquid crystal. You know, liquid crystal is very expensive. The process is pretty low. It's difficult. So if the mass product maybe for this building costs a lot. So it's not useful for the huge applications. But however, our invention is pretty simple. It's a cost like a water, almost no price like a water. So you just put into the water, it's become. So it's we call it copolymer. So this kind of polymer actually can be aggregated with increase of the temperature. So we call this materials the temperature dependent materials. So you can see here. So it's low temperature, it's low particles. That means it's a polymer is a 3 polymers. So and the increase in temperature, it becomes small particles. So if this particle size is comparable with the light, so you can see some scattering. So that's why it's become optical. So from here you can see, I'll give you examples. So here's a container inside with some small polymers. If low temperature, so this can use small particles. So its beam can pass this. We call it transparency. But however, if the particle is big enough, it's comparable to the light wavelength. So you can say this has some scattering. So its light can be broad. So let me show you later how that works in our demos here. So how to use these materials? That's very simple. So suppose you know this glass. It's a green roof house. It's not glass. Some green house we use a glass roof house. So it's a roof is a glass. But however, in summer, it's some problem. Why? Because it's hot. So its temperature increase is this room is temperature rise a lot. So it's very hot. It's not useful for these guys. But in the winter it's fine. But in summer it's terrible. But however, if you use our smart polymer inject in the glass, so it's a change totally. So you can see here is a glass roof. It's a smart polymers. And the sun goes in, and inside the temperature increase, and this smart become black. That means if I apply the sun, totally reflect. So the inside temperature you keep a certain value. That means you can keep the room temperature. And if in the night it's become low temperature, it's become bright again, it's transmission again. So this materials is what we call use the smart materials. And here is a transition. That means you can tune the temperature. That means you can use the temperature you can change. So with different applications, you can tune the temperature. You just change the additives of the polymers inside. So here is a show. This is a low temperature is transparent. It's like a water, and the high temperature is become opaque. So you can see it's a different change. And here's a demonstration. So this materials you can apply the voltage. So this is like this. It's a smart window. So you can apply the voltage, and then later you can say in the center it's become black, become white. Why? Because this change from small particle and big particles. So this is a phase transition. And the high temperature, can say, is a black, or it's a window. So we can fog windows sometimes. Another one we introduce the smart drugs. Smart drug is very useful for the drug delivery or smart drug release. So what's a smart drug? So smart drug is a co-share microsphere. So co-share like a chocolate. Yeah, inside is a large. On the core is a chocolate. So it's a co-share, but the size is a micron. How small? Like here. So very small size. So it's very difficult to make such small size co-share materials or co-share sphere. But however, in our invention, we use a microfluidic applications. So this process can be mass product of microsphere. So you can see here, when we use this process, you can make particles like this. What's a particle like this? It's a co-share. Okay. So this co-share structures. So in the core is a liquid. So we can use a drug. We use an aspirin solution as a core. The share actually is a cross-link share. It's a solid. And in the core, we adapt it or mix with nanomagnetic particles. You know, magnetic particle mixed with a shear is become magnetic shear. The inside is a drug, and there's some pores of the shear. So its size is very uniform. So this process is very useful for the drug release. So let me show you how that works. So it's easy target. Why? Because suppose you have tumor in your stomach. So if you guide your particle with a magnetic field, and then you just use a magnetic field to stop this drug, and then you apply injection magnetic field, you can release purposely. So this is another one we call drug release. So you can use a magnetic field to control the drug release time, and also this material is biocompatible. So you can small in no problems. So it's biocompatible. So no any harmful for your health. And here you can see, you can control this sphere with a magnetic field, rotate, and even you can guide these particles. So that means this material, this particle, you can guide with a magnetic field. So we can with this magnetic field guide magnetic field guided microspheres. And here you can see. So here shows this without application of magnetic field. So this is spherical. However, if I apply magnetic field, so it's become, it's an expansion in one direction along the electric field. So if I apply the ASA electric field, it's like a pump. It's like a pump. So this drug can be released from inside to outside through this core. So we call it a small drug release. So here's a property. So you can say how to control the drug release. Two conditions. You can control the magnetic field. That means you can increase magnetic field. Next one, you can control the vibration frequency. So you can control the electric frequency. You can control the release time. From this, we show you how does this work. Suppose here's a drug, here's a magnetic drug, and this you can guide with a magnetic field and go to the target. So this target is stomach. So you can stop this drug, smart drug with a magnet, and then suppose here's a tumor here and some drugs inside, and just apply magnetic field. So this drug release can treat the tumors or cancers. But however, it's difficult to treat the blood. That's because there's some problems with size. But however, the stomach is easy. Okay, so let me conclusion for three types of materials. One is an ER fluid. So its applications, engineering. So we can use a damper, clutch, and you can use a digital fluidics, use a logic. So actually we have some patents with logic or fluid control, or you can use a bio microsystem. You can use a micro mixer, micro pump. So we have patent. Yeah, we have 5 patents, US patent, with different device patent and the materials patent. And next one is a smart polymers. So what applications? Applications is a smart window, smart roof, and also you can construct a private room a conference, and then you can have a bathroom. That's because some hotel is a window, is a bathroom, use a glass. But you have to close your bathroom, otherwise some guys will watch you, right? That's problems. But however, you can change your bathroom windows. You just turn on your electric field or voltage. And then you can make a large panel display. This is very important. Why? Because liquid crystal display is very expensive, huge panel. But this guy is very cheap, like a water. So don't care about its price, but you just design how to make this work. The next one, last one is a smart drug. So this material is very useful for the smart drug delivery. And you can use engineering. Why? Because some U.S. company, contact with us. This material is very useful. Suppose you put in glue inside. If you apply electric field, you can release suddenly. So we can use the active glue. So it's very useful for glue. Another one, you can use a smart elastomer. Smart elastomer, you can use a damping system. Even you can use a train damping system. Use this materials. Okay, so thank you very much. Okay, we are going to show what? Yeah. Water. Oh, it's not. Yeah, in the center region, it's because apply the voltage, his temperature increase. So you can say change a little bit. You use the water, give water. See? Yeah, it's just like a battery. Yeah.
Can you change it even further?
Yeah, sure. It's high voltage. We just low voltage.
Okay.
Yeah.
This not lunch normally. I understand that everybody who comes here, time is precious. So we work with a very tight schedule. We try to finish before 2 o'clock. And what we would like here is that's the reason why we have today you come in. It's all very quickly done. Because we really don't want to miss the chance of the professor to show us what he has to say.
Yeah, I will show you this smart window is a timer fast. Hot water. Yeah. Hot water. Yeah. We just change temperature. The half is hot water, half is cool. So you can say half is a transient. Yeah. Here. It's a hot water. We just show you quickly. Yeah. Okay, so here's hot water. It's temperature. You just put this inside. Very fast.